So, welcome again to the engineering chemistry course. Before starting the today's class, let's have the recap of the previous class. In the last class, we have discussed about the manufacturing of metallurgical coke by Otto Hoffmann's oven method, in which we have discussed in detail the construction and working of the Otto Hoffmann's oven. After that, we will learn about the recovery of the various useful byproducts in the Otto Hoffmann's oven method. By finishing this topic, we completed the solid fuels. In the today's class, we will start with the new topic liquid fuels, in which following topics we will going to discuss today: advantages of liquid fuels, crude oil, mining of petroleum, refining of petroleum, and introduction about the cracking process. So let us begin with the advantages of the liquid fuels. The major advantages of the liquid fuels are its high calorific value. As compared to the solid fuels, the calorific value of the liquid fuels are much higher. Since these are in liquid state, that's why lesser furnace space is required for their storage. Third, after combustion, they do not leave ash, so there is no problem of the ash disposal. And fourth important advantage is these are easily ignited. These can be easily ignited. So these are the four main advantages of the liquid fuels. All the major categories of the liquid fuel are obtained by the crude oil, which is called the petroleum. It is the important primary fuel. It must be noted that petroleum or crude oil is the primary liquid fuel, while petrol, which is obtained by the petroleum or the crude oil, is the secondary fuel. So basic oil is the petroleum oil or the crude oil, which is the primary liquid fuel. It is a dark greenish brown viscous oil found deep in the earth crust. It is formed millions of years ago by anaerobic decay of debris of plants and animals, which are buried due to volcanoes under the influence of high temperature and pressure. Due to the slow degradation process, the organic debris converts into alkanes, which on isomerization and crystallization forms the crude oil. So now question arises, how this crude oil or petroleum we can obtain. The process of obtaining the petroleum from the deep earth crust is called the mining of petroleum. We know that the petroleum is present deep below the impervious rocks. Mining of petroleum is done by drilling holes in the earth crust and sinking pipes up to the oil-bearing porous rocks. Usually, oil rushes out itself due to the hydrostatic pressure of natural gas, or it may be pumped up using an air lift pump or a lift pump. This is the air lift pump consists of two coaxial pipes or coaxial pumps. The air lift pumps consist of two coaxial pipes lowered into the oil bed. These are the pipes. The compressed air is forced through the outer pipe. This from there the compressed air is forced. When the compressed air is forced through the outer pipe, it causes the oil to flow out through the inner pipe. From here the oil moves in the upward direction and we can mine the petroleum or the crude oil. In this way, crude oil can be mined. Now, composition of the crude oil. As we know that the main component, because the crude oil is the hydrocarbon oil, so the main component is the carbon, 80 to 87%, hydrogen 11 to 15%, nitrogen 0.4 to 0.9%, oxygen 0.1 to 0.9%, sulfur 0.1 to 3%, and metals less than 0.1%. This is the basic composition of the crude oil. Now, this crude oil obtained directly from the ground is a viscous, dark colored liquid consisting a mixture of solids, liquids and the gaseous hydrocarbons having a lot of impurities. For example, sand, brine, etc. That's why it is called the crude oil, because it is not in the pure form. It is in the raw form. That's why it is called the crude oil. So the process of removal all type of impurities from this petroleum or the crude oil and separation of its various useful fractions is called the refining of petroleum. So basically, what is refining? Refining involves two processes. First is the removal of impurities and second is the separation of various useful fractions from the crude oil. So let us discuss in detail the refining process of the petroleum. As just now we have discussed that the refining of petroleum involves two steps. First is the removal of impurities. Second is the fractional distillation. So removal of impurities is done in three steps. In the first step, removal of the water completed. In the second step, removal of various salts like sodium chloride and magnesium chloride is done. And third one is the removal of the sulfur from the crude oil is done. So in the first step, various type of impurities are removed from the crude oil. Mainly three types of impurities are present which are removed in this step. These impurities are water, salts and sulfur. Second step is the fractional distillation. What is fractional distillation? Fractional distillation is the separation of different useful fractions in fractional distillation chamber from the crude oil. So we will going to discuss in detail the removal of the impurities and the fractional distillation. First is the removal of water. For the removal of water, demulsification process is done. In this, water is removed from the crude oil. First, the emulsified water along with the salt dissolve is removed by passing the crude oil between highly charged electrodes. This is the important step. The crude oil is passed through the highly charged electrodes. The colloidal water droplets unite on positive electrode to form the large drops which separate from the oil. This process is also called the Cottrell's process. I am just repeating now. The crude oil is an emulsion of oil and salt water, that is the brine. So to remove the water from this crude oil, demulsification process is done. It is achieved by the Cottrell's process, in which the crude oil is allowed to flow between the two highly charged electrodes. As a result, the droplet of colloidal water coalesces to form large droplets which separate out from the oil layer. So in this way, the water get removed from the crude oil. Second is the removal of the salt. Generally, in the crude oil, sodium chloride and the magnesium chloride is present, which can be removed in this process. These are removed by simply washing with the water. Third is the removal of sulfur. After washing with the water, the crude oil is treated with the hot copper oxide to remove the sulfur from the sulfur compounds in the crude oil. Actually, this copper oxide reacts with the sulfur present in the crude oil and get converted into copper sulfide. So in this way sulfur is removed from the crude oil. It is necessary to remove all type of these impurities from the crude oil and separate all the hydrocarbons in order to make each fraction available for appropriate use. Therefore, this step is mandatory, or it is the essential step for the refining process. After removal of all type of impurities, the next step is the fractional distillation. Fractional distillation is the process in which various useful products or the components of the crude oil are separated according to their boiling ranges. In this process is carried out in the fractional distillation chamber. This is the diagram of the fractional distillation chamber. In this process, a crude oil is first heated to about 400 to 450 degree centigrade in an iron retort, where all the volatile constituents are converted into vapors. Now, the hot vapors are then passed through the fractional distillation chamber, which is also called the fractional column. This column is a tall cylindrical steel column around 31 meters high and 3 meters in the diameter. The column is provided with a number of steel trays. These are the steel trays. Number of steel trays at a short distance. Each tray is provided with a small chimney with a loose cap. This is the small chimney with a loose cap. This. Each as the vapors of the oil rises up, they become gradually cooler and fractional condensation takes place step by step at different stages of the column. The heavier component having the higher boiling points are first cooled and condensed, while the lower boiling fractions will condense later. The uncondensed gases escape out through the top. So, in this fractional distillation chamber, at the uppermost part, uncondensed gases are obtained. Then next, petroleum ether is obtained. Up to next, petrol, naphtha, kerosene, diesel, and at last, at the bottom of the fractional distillation chamber, heavy oil is obtained. Clear? So I am again repeating, in the fractional distillation chamber or the fractional column, different fractions of the crude oil are separated according to their boiling ranges. The heavier component having the higher boiling point are cooled down at the bottom part and get collected at the bottom part, and the lighter components, that is the uncondensed gases, petrol, ether, these are collected at the upper part of the fractional distillation chamber. So basically different useful products are separated out in this fractional distillation chamber according to their boiling ranges. As the number of carbon atom increases in the hydrocarbon or the component, their boiling point also increases. So this is the comparative chart of various useful byproducts recovered in the fractional distillation chamber. Uncondensed gases which are having the boiling range below 40 degrees centigrade, containing carbon 1 to carbon 4, C1 to C4. That means total number of carbon atom that they contain 4, maximum up to 4. These gases may be used for the domestic and industrial fuel under LPG name. Second is the petroleum ether, having the boiling range in 40 to 70 degrees centigrade, containing 5 to 7 carbon atoms, may be used for the aeroplane fuels, helicopters, or can be used as a solvent. Third is the petrol or gasoline, boiling range 60 to 120 degrees centigrade, containing 5 to 8 carbon atom, used as a fuel for petrol engines, can be used for dry cleaning or can be used as a solvent. Fourth one is the naphtha or the solvent spirit. The boiling range is 120 to 180 degrees centigrade, containing 7 to 10 carbon atoms, can be used as a solvent and for dry cleaning purposes, and in chemical industry it can be used. Next is the kerosene. Boiling range is 180 to 250 degrees centigrade, containing 10 to 16 carbon atom. It can be used for illumination, domestic fuel, for oil gas and fuel for jet engines. Next is the diesel, having the boiling point 250 to 320 degrees centigrade, containing 15 to 18 carbon atom, can be used for the diesel engine fuel. Last is the heavy oil. Boiling range is 320 to 400 degrees centigrade, containing 17 to 30 carbon atom and used for making petrol by the cracking process. So this is about the refining of the petroleum. I am again repeating, refining involves two steps. First is the removal of impurities and second one is the fractional distillation. In the first step, all the impurities are removed from the crude oil, while in the second step, various useful fractions are collected separately from the crude oil. Now, coming towards the next topic, next important topic, that is the cracking. Cracking is defined as the process of the decomposition of the higher molecular weight hydrocarbons into lower molecular weight hydrocarbons. For example, decane in presence of high pressure and temperature converted into normal pentane and normal pentene. So, larger hydrocarbons are breaked into lower hydrocarbons. This process is called the cracking. Basically, the cracking process may involve following processes. First is the rupture of carbon-carbon bond and carbon-hydrogen bond in the high molecular weight hydrocarbons. For example, here rupturing of the carbon-carbon bond in decane result in the formation of the pentane and pentene. Second possible change is the cyclization. It may possible that the long chain hydrocarbon converted into the cyclic product. Third possible change is the formation of unsaturated hydrocarbon from the saturated hydrocarbon. Fourth is the branching of the straight chain alkanes may takes place. So basically during the cracking process, higher molecular weight hydrocarbon converted into the lower molecular weight hydrocarbon, in which breaking of carbon-carbon and carbon-hydrogen bond takes place. Second, in this process, cyclic products may form. In this process, unsaturated hydrocarbons may form, or branched hydrocarbon may also form during the cracking process. Now question comes, what is the need of the cracking? We know that among all the fractions obtained by the fractional distillation of petroleum, gasoline has the largest demand as a motor fuel. Gasoline is the petrol, but its yield is only 20% of the crude. Also, the quality of the so-called straight run gasoline. What is straight run gasoline here? This straight run gasoline is the gasoline obtained by the fractional distillation of the crude oil. So the quality of this straight run gasoline is very low. Moreover, there is a surplus of heavier petroleum fractions. Look at here again. Now this is the straight run gasoline. Its yield is only 20%, while we have received at the bottom of the fractional distillation chamber a large amount of heavy oil. Petrol is the combination of the hydrocarbons containing 5 to 8 carbon atom, while gasoline is the combination of the hydrocarbons containing 17 to 30 carbon atom. So the process by which we can convert this heavy oil to the petrol is the cracking process. It is simply the breaking of higher molecular weight hydrocarbons to the lower molecular weight hydrocarbons. So by the cracking process we can increase the production of the petrol. So to overcome these difficulties, the middle or the heavy fractions are cracked to get petrol. The petrol obtained by cracking is of superior quality than that of the straight run gasoline, because the cracking process increases the octane number of gasoline. Later in our next lectures, we will discuss the importance of the octane number of petrol. So increase in the octane number of gasoline means increase in the quality of the gasoline. Second, it also improves the anti-knocking properties of the gasoline. Both octane number and anti-knocking properties are directly related with the quality of the gasoline. So the petrol or the gasoline obtained by the cracking process is of higher quality. Now coming towards the types of cracking. Basically, the cracking process is of two types: thermal cracking or catalytic cracking. Process is the same. What is the process? This is the conversion of the higher molecular weight hydrocarbons into lower molecular weight hydrocarbons. So if this process is carried out at high temperature and pressure, then it is called thermal cracking. If it is carried out in presence of catalyst, then it is called the catalytic cracking. The thermal cracking process is of two types: liquid phase thermal cracking and the vapor phase thermal cracking. While the catalytic cracking is of two types: fixed bed catalytic cracking and moving bed catalytic cracking. Let us look the differences between the liquid phase and the vapor phase thermal cracking. Basically, the liquid phase thermal cracking is carried out at 475 to 530 degree centigrade temperature, while vapor phase thermal cracking is carried out at 670 to 720 degree centigrade and 1 atmospheric pressure, while in liquid phase pressure range is 7 to 10 atmospheric pressure. Look at the difference here. Here the pressure is so high, while here it is done at the atmospheric pressure. Due to the high pressure and comparatively low temperature, the raw materials are present in the liquid phase, while in this process temperature is too high and pressure is normal pressure. That's why all the raw materials, that is the heavy oil, is present in the vapor phase in this process. Third one is the yield of gasoline is about 60 to 65% in liquid phase thermal cracking, while in vapor phase thermal cracking the yield is only 70%. Obviously, at this high pressure and 475 to 530 degree centigrade temperature, all the reactants or the raw materials are in liquid state, while in these conditions all the raw materials are in the vapor phase. So basically these are the thermal cracking processes. Thermal cracking processes, that means when the cracking process is carried out at high temperature and pressure. So in this process heavy oil is converted into the petrol. Now time for the revision. What we have discussed or learned in today's class: we have started with the advantages of the liquid fuel. Then what is the crude oil? We have learned mining of petroleum or mining of crude oil and the refining of the petroleum we have discussed, in which we have discussed that the refining process is the two-step process. First step is the removal of impurities. Second step is the fractional distillation. Then we have started with the introduction of the cracking. What is the cracking process we learned? Second, what is the need of cracking process? Thirdly, types of cracking process we have started with, in which brief idea about the thermal cracking I have given to you in the today's class. So that's all for the today's lecture. Now it's time for the learning check. Please pause the video for a minute and think about this question on your screen. Cottrell's process is used for removal of sulfur from crude oil. B. Removal of sodium chloride from crude oil. C. Removal of water from crude oil. D. Removal of magnesium chloride from crude oil. Yes, you are correct. It is used for the removal of the water from the crude oil. So that's all for today's class. Thank you. Take good care of yourself and keep enjoy e-learning at home. Thank you.